Hello, my name is Desmond Idagise and I'm your maths teacher. We've been looking at the theme numbers and numeration, and so far in this series of videos we've been studying indices. We've learned about the 6 laws of indices. Remember, we learned about the product law of indices, the quotient law of indices, the zero law of indices, the power of a power law of indices, the negative index law of indices, and finally we learned about the fractional law of indices. I guess that's so much for us to learn, and I'm sure things have stuck to your mind. Now we're going to do some exercises to see how far we can recollect. Let's go into our class quickly. Alright, so now we've looked at all the laws, from our product law to our quotient law to our zero index law to our fractional index law, and now we want to see if we've been able to catch up so far. Let's do some exercises quickly and let's see if we remember to apply such laws in our questions. Quickly, let's see this example. If you are given such a question to simplify the expression, what comes to your mind? How would you write this? First, when we work in indices, it is preferably that you don't work with decimal points. So you could convert that decimal point into a fraction so that you better understand. 1.5 would simply mean 3 over 2. So if we rewrite this equation, we'd have something like cube root of 4 all raised to the power 3 over 2. If we go on to still rewrite this, it will give us what? 4 raised to the fractional index 1 over 3, which of course we told you is the nth root. This all over 3 and 2. Our index law, this would give us 4 raised to power 1 over 3 times 3 all over 2. This cancels out and we would have 4 raised to power half. Of course, we don't leave it like this. We go on to say this is the square root of 4, and at the end of the day we get our answer as 2. If we see this question, we've used laws that we've learned so far. Can you notice some of those laws? On your own, try and see if you can notice some of those laws. Meanwhile, let's go on to other questions. If we have something like this, how would we solve this? We would have what? 4 times 3. Remember we said, get the like terms together. Terms that have things in common, like numbers. Put them together on one side of your equation and put the letters on the other side. So you would have 4 times 3, and then you have a raised to power 3 times a. We said any quantity left to itself is the same as that quantity raised to power 1. So we would have a raised to power 1 times b raised to power 1 times b raised to power minus 2. So let's work this out. We would have what? 4 times 3, 12, times a raised to power 3 plus 1 times b raised to power 1 plus minus 2. And this would give us what? 12 times a raised to power 4 times b raised to power 1 plus minus 2 would be 1 minus 2, which at the end of the day is minus 1. And of course, this gives us 12 a raised to power 4 all over b raised to power 1. Of course, we have no need to write it, so we leave it in this form. I hope we are understanding. Let's take a look again at another example. For instance, if you were asked to find the fourth root of 16a raised to the power minus 12. From our knowledge of the laws of indices, how would we go about solving this? Let's take a look. This could be broken down in two parts. But first, let's simplify this. We would have 16 all over a raised to power 12. And then we have the fourth root of all of this. If we were to find the fourth root of 16, that would be 2 all over the fourth root of a raised to power 12. Further simplifying this, we would have 2 all over a raised to power 12. And then instead of writing the fourth root, we could write it as all of that raised to the power 1 over 4. This, of course, is a raised to power 12 times 1 all over 4. And this gives us 2 all over a raised to power 3. That would be our answer. Let's take a look at this one. We said further on in our class that we collect like terms. So we would say 2 raised to power half times this 2 raised to power 3 over 2 times x raised to power half times this x raised to power 3 times 3 over 2. If we go on to simplify this, we would have 2 raised to power half plus 3 all over 2 times x raised to power half plus, here would have 9 over 2. Let's go on. Here would have 4 over 2, which would give us 2. And here would have 1 and 9 is 10 over 2, which would give us 5. This would give us 4x raised to power 5. And that's our answer. If you were asked to simplify this expression from the laws of indices we've learned so far, this shouldn't be a problem for you. Quickly, we would say this could be rewritten as 2a raised to power minus 2 divided by a raised to power minus 3 all over 2. Using our quotient of power law, this would become 2a raised to power minus 2 minus 3 all over 2. And of course, this would give us what? 2a raised to power minus 2 plus 3 all over 2. If we go forward, we would have 2a raised to power minus 4 plus 3 all over 2. This, of course, would give us 2a raised to power minus 1 over 2. Remember, from the negative power law of indices, this would be what? 2 raised to power. This our a becomes inverted. And of course, it's still raised to the power half. But it's no longer negative. Now it's positive. Also, from our fractional law, we said this would give us what? 2 all over root a. And so we have our final answer. Let's take a look at this other example here. Simplify a raised to power 2 times a raised to power 5 divided by a raised to power 3, all enclosed in bracket, raised to power 3. Quickly, we could write this out as a raised to power 2 times a raised to power 5 all over 3 times 3 here would give us a raised to power 9. Using both our quotient of power law and our product of power law, would have this as a raised to power 2 times a raised to power 5 divided by a raised to power 9. This of course would give us a raised to power 2 plus 5 minus 9. Our powers here of course 2, 5 and 9. So we have a raised to power 2 and 5 is 7 minus 9 would give us minus 2. Again, from our negative power law, we would have what? 1 all over a raised to power 2. And that is our answer. If you were asked to simplify 72a raised to power 3 times b raised to power minus 2 all over 2a raised to power 5 times b raised to power minus 6, all enclosed square root of all of that, how would you go about solving this? In a straight line, would have the square root of 72a raised to power 3 times b raised to power minus 2 divided by our denominator 2a raised to power 5 times b raised to power minus 6. Now if we took like terms, like we learned earlier, we would divide 72 by 2 and would have what? 36. Again, if we took like terms, our power here 3 would subtract our power here 5 because of the operator, which is a divisor. So we have 3 minus 5. Also, taking like times of our powers b, would have b raised to power minus 2 minus 6. Our power here minus 6. So this would give us what? Square root of 36 a raised to power minus 2. 3 minus 5 is minus 2. b raised to power minus 2 minus 6 would give us minus 2 plus 6. Minus 2 plus 6, of course, would give us 4. If we express this in another form, this would be 36a raised to power minus 2 times b raised to power 4, all enclosed, raised to power half, from our fractional index law. Now, remember we said anything enclosed in the bracket, every single operator, every single element within the bracket is acted upon by the operator outside of our bracket. So, our power, 1 over 2, will operate on everything within the bracket. And of course, if we opened up our bracket, we would have what? 36 raised to power 1 over 2 times a raised to power minus 2 times 1 over 2 multiplied by b raised to power 4 times 1 over 2. If we continue to work this out, we would have 36 raised to power 1 over 2 simply means the square root of 36. which would give us 6. A raised to power minus 2 times 1 over 2 would give us A raised to power minus 1. And B raised to power 4 times 1 over 2 will give us B squared. And this, of course, will give us 6B squared all over A. Our A raised to power minus 1 has become inverted. And so we have our final answer. Let's take a look at this question here. It says rewrite the following using positive indices only. That means if we lay this out, this would be A raised to power 2 times B raised to power minus 3 times 2. This, of course, will give us A raised to power 2 times B raised to power minus 6. We cannot leave the answer this way, especially since we've been asked to rewrite it using positive indices only. So from our negative index law, this our B here becomes inverted. Hence we have A raised to power 2 all over B raised to power 6. Our power minus 6 has become positive 6. So in our answer here we have no negative annotation. Therefore we've written this expression using positive indices. Students, let's take a recap of all that we've learned so far. We've learned that indices is a shorthand manner of writing numbers that repeatedly multiply themselves over and over again for a number of time. Also, we learned about the laws that govern indices. 6 laws in total. If you remember, we learned about the product of power law, which states that for like bases that multiply themselves, we simply add up the powers. Next, we looked at the quotient of power law, which states also that for like bases that divide themselves, we simply subtract the powers. The next law we looked at was the power of a power law, which states that if a quantity A is raised to a power m and again raised to another power, we simply multiply our powers across the brackets. Next, we looked at the zero index law. Very interesting law, which states that any quantity, as long as it is raised to a power 0, is equal to 1. So irrespective of its largeness or its smallness, if it is raised to a power 0, it is equal to 1. Next, we look at the negative index law, which states that any quantity raised to a negative power becomes 1 all over that quantity raised to the power n, in this instance, positive. Finally, we looked at the fractional index law, which states that if any quantity A is raised to a fractional power 1 over n, for instance, would have the nth power of that quantity. So if n, for instance, is 2, would have the square root of our quantity A. If n was 3, would have the cube root of our quantity A. If n was 4, would have the fourth root of our quantity A. We also explained that instances where we have, for instance, our fractional power as m over n, our m here represents a whole number power, while our n represents a fractional power. Finally, with all that we learned from these 6 laws, we did exercises that helped us to explain better these laws and to help us practice also to become better at solving problems involving indices. With this class, I'm very sure that after now, if you come across problems in indices, it will have no problem at all. I'm glad I took you on this class, and I'm sure you enjoyed yourself too. I look forward to seeing you in our next series of videos. Once again, my name is Desmond, and I will see you next time. Bye for now.